Let's look at question number 24. For the disproportionation reaction, it is a must that there should be at least one question from disproportionation. So, for the disproportionation reaction, 2Cu plus giving Cu solid plus Cu2 plus aqueous at 298 Kelvin, we have to find out ln K, where K is the equilibrium constant. Now, how will you solve it out? First of all, dear friends, see this disproportionation reaction can be written as the oxidation half plus the reduction half, right? So, let me write it like that. First, let us talk about the oxidation half. Yes, tell me. In oxidation, what will happen? This Cu plus aqueous is going to get converted into Cu2 plus aqueous. Okay. The E naught over here for Cu plus to Cu2 plus. See, dear friends, over here the value is given to be 0.16, but since I am reversing, the value will be minus 0.16 volt. Okay. Now, let us write the reduction half. When I write the reduction half, so here you will be having Cu plus aqueous forming Cu solid, and here the E naught of Cu plus to Cu should be given. Yes, it is given, the value is 0.52. Okay. Now, I have to add the 2 to get the E naught of the cell. Okay. So, E naught cell, as I said, I have to add the 2 values. So, it will be minus 0.16 plus 0.52, which is equal to 0.36 volt. Okay. Now, also we know that the relation between E naught cell and the equilibrium constant is this. I have to find out ln of K. So, it will be 0.36 RT by NF. N is because one electron is lost and one is gained. So, N is the value of N is 1, and this value is given to be 0.025. So, this is 0.025 into ln K. On solving, I will be getting ln K is equal to 0.36 by 0.025. On solving, I will be getting 14.4. Is it the right answer? No. Why? Because he is asking the answer as this into 10 raised to power minus 1. So, 14.4 is not the right answer. The right answer will be 144 into 10 raised to power minus 1. So, in the blank portion you have to write 144. Okay. So, this is the right answer. Now, let us look at question number 25. The ratio of the mass percentage of carbon and hydrogen and carbon and oxygen of a saturated acyclic organic compound X are 4:1 and 3:4. We have to make a formula out of it, isn't it? So, let us see. Mass of carbon by mass of hydrogen is given to be 4:1. Mass of carbon by mass of oxygen is given to be 3/4. Right. Let us assume that the mass of carbon is 4, say 4 grams. Okay. So, if I am assuming mass of carbon to be 4 gram, mass of hydrogen will be equal to 1 gram and mass of oxygen will be equal to 16/3 grams. Right. Now, I can simply calculate the number of moles from here. So, the number of moles of carbon in this molecule will be 1/3 that is 4 by 12. Number of moles of hydrogen would be 1. Number of moles of oxygen will be 16 by 3 by 16 will be 1 by 3 moles. Okay. So, what is the empirical formula? If I multiply this whole by 3, so I will be getting C1H3O1, or you can also write as CH3O. Do you know any such compound CH3O? No. So, this is an empirical formula. Now, we are not given anything else. So, we will consider the molecular formula to be C2H6O2. C2H6O2, right? Can you make a compound out of it? Yes. So, this is the correct formula. Now, what we have to do is we have to find out the moles of oxygen gas required for the complete combustion of 2 moles of this X. Okay. See, the combustion equation will be C2H6O2 plus. See, I am giving you a generalized format also. So, in future also you can use this format. Whatever is the number of moles of carbon, write it as it is. The moles of hydrogen, divide this by 4, right? And the moles of oxygen, you have to subtract and divide by 2. This is O2 gas. Fine. And this all should be giving you, how many carbon moles are there? 2. So, it should be giving you 2 moles of carbon dioxide gas plus how many moles of hydrogen are there? 6. Should be giving 3 H2O liquid. Now, this is the standard equation. There are 2 ways to do it. First, you write down the whole equation on the basis of carbon and hydrogen. Check over here how many oxygens are there? 4 plus 3, 7. And how many are over here? 2. So, for 1 mole of the compound require 5 moles of O, that is oxygen. But suppose if you are being asked for 2 moles, like in this case he is asking for 2 moles, it means the answer should be 5 moles of oxygen gas, 5O2. Okay. But anyways, this is also one of the standard way. Now, when you solve it out, what is it that you are going to get? On solving, see 2 by 2 is 1, 6 by 4 is 1.5. So, 2 plus 1.5 is 3.5, minus 1 is 2.5. So, you get 2.5 moles of O2. Now, this you are getting for 1 mole. For 2 mole, it should be multiplied by 2. So, the right answer is 5 moles of O2. So, dear friends, there are 2 ways in which you can solve this question. One, use the standard equation, write it like this for oxygen, or just on the basis of carbon and hydrogen, check the moles of carbon dioxide and water formed, check the oxygens over here, subtract any oxygen which is present over there, and you will get the moles of oxygen, right. So, for this question, the correct answer is 5 moles of oxygen will be required for complete combustion of 2 moles of this compound. I hope that you have enjoyed this session, understood all the solutions, right.